This formula chart just reviews how to find the area of some of the shapes that you might see when finding the area of composite shapes. First here we have a triangle. It says that the area is equal to the 1/2 times the base times the height. So in our example here, our area is going to equal 1/2 times our base of 12 times our height of 5. And one thing to keep in mind is that our height refers to our altitude, meaning that it's a segment that's perpendicular to the base that connects to the top vertex. All right, so 1/2 times 12 times 5 is 30. So this is 30 square inches. Next, we have parallelograms and rectangles, and they have the same formula. The area is just equal to the base times the height. So in this case, we're just going to multiply 3 times 4, which gives us 12 square centimeters. And again, our height is always going to be perpendicular to our base, whether we're talking about a parallelogram or a rectangle. Rhombuses and kites also have the same area formula. It's 1/2 times d1, d2, where d1 and d2 refer to the diagonals of the quadrilateral. So here in our example, we have a kite, and d1 and d2 are 3 and 6. So the area is going to equal 1/2 times 3 times 6. And that comes out to 9 square meters. Now let's look at our trapezoid. So for this one, we have 1/2 times the sum of the bases times the height. So we'll add 9 and 13, and we'll multiply by that 1/2 and 10. So 1/2 times the sum of 9 and 13 times 10. And that comes out to 110 square kilometers. So let's take a look at regular polygons. The area of a regular polygon equals 1/2 of the apothem times the perimeter. In our example, the apothem is 6, and the perimeter is going to be 5 times 8, since this is an octagon. So our apothem is 6, and our perimeter is 40. So then the area is going to be 1/2 of 6 times 40. So in this case, it comes out to 120 square feet. For a circle, we just use pi r squared. So here we'll have pi times 3 squared, and we could just leave that as 9 pi. I'm going to write 9 pi square miles. Down below, we have a semicircle, so that's almost the same formula. It's just 1/2 pi r squared. 1 squared is 1, so this just equals pi over 2. And that's pi over 2 square millimeters. Next, we have a quarter circle. That's just 1/4 pi r squared. So for this, 5 squared is 25. So we have 25 pi over 4 square yards. And we can actually find the area of any sector of a circle just using a proportion. What we do is we compare the central angle to the total number of degrees in a circle, and then we say that that's equal to the area of the sector over the area of the whole circle. So we compare part whole, part whole. In this case, M is 120. That's over 360 degrees in a circle total. And the area of the sector is going to be on our top, on our numerator of our second ratio over here. And the denominator is going to be the area of the entire circle, which we can't see, but we know it would be pi times 9 squared. So there's our proportion. We can cross multiply and divide. I'm going to simplify a little bit first because I know 120 times 3 equals 360. And now my cross products give me a simple little equation. 81 pi equals 3 times the area of my sector. So I'll divide both sides by 3. 81 divided by 3 is 27. So I know that the area is going to be 27 pi meters squared.